This is the part 1 of the video lecture on water. So we're going to start off this chapter by talking about an example of water loss. So water is circulated throughout the entire world through the water cycle, and we'll learn about that a little further along in the lectures. But this is a really good example of how we have redistributed water throughout the world, and how we have made certain places drier and other places wetter. This is an example of one area where we've made this situation worse. Lake Chad in Africa, about 5,000 years ago, this area was much wetter, and that had, of course, to do with different types of rainfall amounts. The area was a different climate, and so there was a lot more water in this area. The lake, though, has receded over time, and one of the main reasons is that this area in Africa, if you can see here, this is where Lake Chad is. You can see that all of these rivers used to run into Lake Chad. So these rivers actually drained into Lake Chad. As you can see, it's a landlocked area, meaning that you don't have any areas feeding into this. Okay, the closest ocean is all the way through Nigeria and Cameroon, and all of these areas rely on Lake Chad water. So the mountains, actually the water from the mountains drains down after the snow melt happens, drains down into tributaries, and then water ends up here. So in these areas, the water runs into this lake. The problem is that so many people in this area use the lake for water, and they've diverted it to their agricultural crops. With that comes the fact that now the lake doesn't get as much water because these areas, right, if you live along this river and you divert the water, then the lake doesn't get as much water. Some of this has happened due to deforestation, but most of this has happened because of the fact that people are diverting water for their agricultural use before it ends up in the lake. And the lake was one of the major areas for people to bathe and to get drinking water from. So this is a big problem in this area. And so the lake has decreased over 90% since 1973, and the reasons are climate change, deforestation, and of course human use. And here's good just images of what everyone uses the lake for. You know, livestock uses the lake to drink. They use it to fish. There's just lots of things that go on in this lake. And here's a wonderful aerial image of the lake. So the blue, of course, represents the water in 1973. Here's all of Lake Chad. As you can see now, this upper part of Lake Chad is now turned into a forest, which means that it's dried up. So it went from a lake stage to dried up to probably a mossy state, and then a wetland state. And then it transitions into a bog state, and then it transitions into a forest state. And you can see here that this area also has been overrun by vegetation. So this is really the only area that's left of water. Big problem in Africa, especially with lack of water. So the water that covers water covers over 70% of the Earth's surface. Of course, there's two different types of water on the Earth's surface. There is fresh water and there's salt water. Salt water encompasses almost all of that 70%. Only a small 2% portion of that is actually fresh water, which is drinking water or water that can be used by humans, and that is a big issue. So a lot of that 2%, about 1% of it is captured right now in glaciers, which of course are melting. One of the big problems with water is the fact that, you know, most of it is in this ocean format. Now and is unusable to humans. Now we have started doing what we call desalination plants, where we take the salt out of the water, and then we pump that water inland. The problem with desalination plants, they're really expensive to run because it requires a lot of energy to heat water up, right? So it would be like boiling tons and tons and tons and tons, well, millions and millions of gallons of water, which requires a huge energy source. So it requires oil or coal or something to heat the water up. And when we do that, it costs money. So desalination is really expensive. It's expensive to build the plant. They need to be on prime real estate because they need to be close to the ocean. And then they need to pump that water to your house. So there's a lot of pros and cons to desalination, and one of the bigger issues, of course, is social justice. So if we increase the price of water, fresh water that comes to your house after we put it through desalination, who can afford that clean water? So remember, there's 70% of the earth is covered by water, but that water is divided into two parts. It's divided into salt water and fresh water. Of the fresh water that's available to us, which is very minimal, about 1% of that fresh water that's available to us is encapsulated in glaciers. So we can't even use it. So we have a very small amount of water on the earth's surface that's usable to the humans without, of course, altering it. This just kind of talks to you about the availability of water in a particular region, and it's calculated by subtracting the potential evaporation from rainfall. In arid regions, water balance coefficients are negative. In the world's deserts, for example, they vary between -200 and -300 centimeters. In humid rainforests or of the world, water balance coefficients are in the positive and exceed 400 centimeters. So, negative and positive depends upon where you are. In general, forests grow where the water balance coefficients are in the positive. Savanna, grasslands, and deserts are found in regions where the coefficients are in the negative. In many places, temperature and rainfall, of course, vary considerably from season to season, just like here. And the water balance coefficients show those variations. So in the southwest of the United States, the rainfall is relatively constant throughout the year, whereas in some areas it's not very constant. So this is the water cycle, and this is really important for you to know. So we have our oceans, and our oceans are here. Most of our water is evaporated off the ocean, and most of our water is precipitated over the ocean. So actually the most rainfall actually is evaporated and falls off of the ocean. Remember, as water is evaporated, it's condensated, or condensation occurs. It forms clouds, and then once those clouds get big enough and they hold the droplets get large enough of water vapor, then it falls to the ocean or to the ground. So we don't really see a lot of this because we're not out on the open ocean. But as it makes its way to land, we call this, of course, precipitation. And precipitation can be in the form of snow, ice, rain, etc. As it falls onto the ground, on land, water either percolates through the ground into groundwater, and it's held below the Earth's surface in what we call aquifers. Or if it hits the ground and runs off, it goes into our streams or river systems or our lake systems. So there is groundwater and surface water in terms of fresh water. Actually, surface water could be oceans as well because it's on the surface. Groundwater is what's below the Earth's surface, and that can be in aquifers, etc. There's also transpiration. So transpiration is water that comes off of leaves. So leaves during photosynthesis, one of the byproducts of photosynthesis is water. So as it goes through the photosynthesis process and converts light into energy, into food, one of the byproducts is water. And water then, when water is evaporated from leaf surfaces, that's what we call transpiration. So besides evaporation from the oceans, transpiration is evaporating water from surfaces of trees, people, etc. It goes up into the atmosphere, it's condensed, and then it comes down in some form of precipitation. As it comes down in some form of precipitation, it either runs off into surface water or it percolates below the Earth's surface into the groundwater. There's also something called watersheds. So watersheds are our river systems and all of its tributaries. They look like veins. I mean, if you look at a map of the United States, they look like major veins that encompass the whole United States. There's different watersheds though. So there's like the Mississippi watershed is a main watershed. It drains almost all of the United States water into the Mississippi River, and then of course that goes out into the Gulf of Mexico. So it's an area of land that drains to form a lake or a river. It's also called a drainage basin. And you can see here, these are just showing you, because water inputs and outputs can be measured, watersheds are ideal units for management and study of water flow. Here are the different the watersheds of the Mississippi River includes nearly 1/3 of the land in the lower 48 states. So this is just the entire watershed of the Mississippi River. So it's huge, as you can see. And then, of course, it's divided into 6 smaller watersheds. So the big Mississippi watershed, and then it's divided into 6 smaller watersheds. So how do we use water? Well, human, of course, water use over half of the water flowing in the Earth stream, and there's both non-consumptive use and consumptive use. So the non-consumptive use is water that returns to the streams and aquifers, and this is examples of non-consumptive use are hydroelectric power, which is our dams that we dam and then create hydroelectric power, water, wastewater and septic systems, etc. Then there's consumptive use, and this is water that is not returned to the watershed, sometimes not to the same watershed. So irrigation, and what do they mean by that, is that water when we irrigate crops is either, of course, soaked up by the crops, or it percolates through to the groundwater system and then we lose that water, unless, of course, we drill a well. And industrial use. So a lot of this is put, let's say it's put into soda. Soda, the main component of soda is water. So then it's shipped around the country and people consume it in their body, and then we urinate it, right? Urinate water, and then that goes into our wastewater treatment plants, and then it becomes non-consumptive use. Okay? Here's a wonderful little graph that shows you how much water consumption and through what purposes in countries. So if you look in the United States, we use 41% of our water for agriculture, but if you look in Indonesia, they use 91% of their water for agriculture. Industry is the mauve type of color, and then domestic use is 13%. So if you look at Colombia, they use half of theirs for agriculture, half for domestic, and then a little bit for industry. And then France uses most of theirs for industry, a little bit for agriculture, and most of it for human use. So these are all different ways that water is used throughout the world, depending upon the importance of industry or agriculture in their economics of the country. This, we're going to talk about stormwater runoff. So this is a big issue. I'm going to come back and talk about stormwater runoff in part 2 of this lecture. So we'll pick up part 2 of this lecture right here.